Hello everybody, we're going to talk about solving quadratic equations again. This time we're going to look at a little bit different kind of quadratic equation. This type has unknown constants in front of, or unknown coefficients in front of the x's and an unknown constant right here. So this could be any number, and this could be any number, and this could be any number. And this is sort of special because you could really take any old quadratic equation. Let's say I had something like this, 0.01x squared equals 1,476x, and maybe this was like plus 9 over here and minus 3 over here. Well, you could rearrange this equation so that it would look like this, so that you put all the x squared terms over here, right? You can switch those because of the commutative property, right, of addition. And then you can bring this x term over here just by subtracting 146 or 1,476x from both sides and bring it over to this side. So you would end up with something like this. And then you could even add 3 to both sides so that this 9 would turn into a 12. And then you'd be left with nothing on that side. So then you would have these 3 terms as your ax squared plus bx plus c. And you know, this b value could be a negative value. It could be negative 1,476. So really, if I can come up with a rule that will solve every kind of quadratic equation like this that has these constants, I can come up with a rule that will solve any quadratic equation, not just something that is in this form, because all I have to do is rearrange the variables or the terms so that it would come out to look like that. Okay, so let's go ahead and do it. Let's just solve this and just treat those variables as if they were the coefficients of the number. So the way I solved this before was I made sure this was a perfect square and that this was an even number. So the way I do that is I multiply by a, so that would be a squared. So I'm going to multiply this whole equation by a and this whole equation by 4. So that way this stays a perfect square and this becomes an even number. Okay, so this becomes 4a squared x squared plus this is 4abx plus 4ac equals 4a times 0 is just 0. Okay, so now I can break this up into a square. So I say that this is going to be 4a squared x squared, and then what times itself is 4a squared x squared is 4ax, right? So 2ax. 2ax times 2ax would be 4a squared x squared. And then I'm going to split this in half, right? So half of 4abx would be 2abx and 2abx. Okay, so 2ax times what gives me 2abx? Well, all I'm missing there is a b, so that means I need to multiply this by a b, and that's also this by a b, right? So 2ax times b is 2abx. So this perfect square is 2ax plus b, quantity squared. So wait, I need to figure out what is my other term. It needs to be b times b, which is b squared. So this needs to be a b squared, but it's not right now, right? So I need to get rid of that. So I'm going to subtract 4ac from both sides. And then I want to make it a b squared, so I'm going to add a b squared to both sides. Okay, so that would mean I'm getting rid of that. I have a b squared. So now I have my quadratic equation that is equivalent to 2ax plus b quantity squared, and it's equal to b squared minus 4ac. Okay, so now something squared is equal to that, so that thing should be equal to the positive or the negative square root. So positive square root of b squared minus 4ac, or the negative square root of b squared minus 4ac. Okay, and if b squared minus 4ac is negative, right, I can't take the square root of it, so we might come back to that, but that kind of limits it, right? I have no real solution if b squared minus 4ac is equal to a negative number. All right, so now I need to get x by itself, so I'm going to get rid of the b, so I'm going to subtract b from both sides, and I'm going to divide by 2a, so I get x equals, so I'm subtracting b from both of those terms, so minus b plus the square root of b squared minus 4ac, and, or negative b minus the square root of b squared minus 4ac. And then I'm dividing everything by 2a, right, to get rid of it. So you end up with this little formula that is called the quadratic formula. Quadratic formula. So a lot of people memorize this, but if you go through the steps, you can figure it out for yourself, that x is going to be equal to either negative b plus the square root of b squared minus 4ac over 2a, or negative b minus the square root of b squared minus 4ac over 2a. So some people write it just simply as negative b plus or minus the square root of b squared minus 4ac over 2a. And notice that this is the same thing. It's just they're simplifying it a little bit to put that plus or minus. So there's really two solutions here. We can break this apart and say, look, if that b squared minus 4ac is less than 0, in other words, it's negative, there's no real solution. If that b squared minus 4ac is equal to 0, right? If it's equal to 0, then I don't have two solutions anymore. It's just the square root of 0 is 0, so it's plus 0 and minus 0, so it just drops out. And there's just one solution, namely negative b over 2a. Okay, and then if b squared minus 4ac is positive or greater than 0, then you have your two solutions, the plus and the minus. Okay, so that is finding out the solution to this original equation, ax squared plus bx plus c, and we'll do a couple of examples in the next video.